So we have a little bit of lecture time left, and I want to use it to introduce the thing that's going to end up being on your homework. I'm actually going to skip over mathematical induction for now, since it's really important and I want to give it the attention that it deserves next time. And instead I'm going to introduce this easy thing, how order is going to work. So here's the syntax. If you take a term and another term, and you stick this between them, then what do you think this is going to be? Can you guess? A term or a proposition? This will be a proposition, right? Same goes for if you stick this symbol between them. A term and a term. Then overall you'll get a proposition. So that's the grammar. It's a lot like, membership symbol worked like that, equal sign worked like that. If you stick a term or a term on either side, you get a proposition. Now for semantics. So, by the way, notice that we're not introducing into our language the greater than or greater than or equal to symbols. That's just to not make as many definitions. This is actually going to be enough. So it's just out of laziness that we're not introducing them. We could introduce them. Okay, so semantics. So this one, when we say x less than symbol y, you might read it as x is less than y. The idea is that it means x comes before y. So when you're counting, there's an ordering, right? 0, then 1, then 2. And the ordering, at least from one step to the next, is sort of put in place by our next operation, right? Taking the successor. So in that ordering, the idea, hopefully, if we have set it up correctly in the end, is that this means x comes before y in that ordering. So we hope that, say, 2 is less than 4. Even though 4 is not the successor of 2, 3 is the successor of 2, we still can say 2 is less than 4. 2 comes before 4. And then this one means what it looks like also. X less than or equal to symbol y means x comes before y or it is y. So it's kind of an or thing going on there. And let me just give the LaTeX. So for these in math mode, you can just literally type, make sure you're in math mode, but you could just literally type the less than symbol on your keyboard. And for this, you can do less than or equal to like that, backslash less than or equal to. Okay, and here comes the formalism. So this is definition 95. Okay, are you ready? X is less than y shall mean x is in y. X is a member of y. Okay, so after all that talking about syntax and semantics and the symbol, it's just another way of writing the membership symbol. That's all it is. And then what's this going to mean? X is less than or equal to y. Y is going to mean x is less than y, defined over here, so x is a member of y. Or x is equal to y. That's it. Let me put it in parentheses. Okay, so this is nothing but an alternative way to write a membership symbol. But there's a reason to introduce it, which is to communicate intention. Sometimes, so it's true that anytime you write this, you could just write a membership symbol instead. But sometimes you just want to indicate that you are using the membership symbol for ordering purposes. Just like sometimes you would like to write the symbol 0 rather than writing this symbol for the empty set to indicate that you are thinking of it as a natural number. You are thinking of it in terms of its interaction with all of these other guys, rather than thinking of it in terms of one of the other many uses of the empty set. So the next theorem you see here, right after we define less than or equal to, which is what I just did, the next theorem is essence of order and succession. So order refers to definition 95. Order refers to this. The ordering in which the natural numbers come is expressed by this relation there. And succession refers way back to definition 89, this next thing. So essence of order and succession. This is a theorem that altogether is meant to capture what it is that definition 95, order, and definition 89, succession, are meant to achieve. And if we have set things up correctly, this theorem should be provable, and it should be pretty easy actually, so this is one you'll do on your homework. and it should be the main thing that we use later on. There are a few exceptions, but mainly, for the most part, we can use just this to do everything else afterwards and pretty much forget about definition 95 and definition 89. There are a few exceptions that I just thought were small enough not to clutter this, not to necessitate cluttering this theorem. So this theorem is where it's at. This is the reason for the maybe weird looking definition of this as membership and of next as this. Why is it this? This explains everything, is that it makes this stuff work. So, okay, so let's look at this. Hopefully this is something that you're happy to see is true, that things are less than their successors. Something is always less than the thing that comes after it. So for example, theorem 96 part 1 justifies saying things like 0 is less than 1, 1 is less than 2, 2 is less than 3. It does not necessarily justify saying that 1 is less than 3. That we will have to look into later on. And the second part also will help us relate things to the less than or equal to symbol. And I just want to end by recalling a famous old saying in mathematics that God gave us the integers and all of the rest is the work of man. And we're kind of going against that or revising that. We don't need to be given the integers, we are constructing them. All we need to be given is set theory, and then all the rest is the work of man.